All right. Now, in this video, we will be talking about Advent of Code, day 1. And this is the problem. So, the chief historian is always present for a big Christmas, but nobody has seen him in months. Last anyone heard, he was visiting locations that are historically significant to the North Pole. A group of senior historians has asked you to accompany them as they check the places they think he was most likely to visit. As each location is checked, they will mark it on their list with a star. They figure the chief historian must be in one of the first 50 places they will look. So in order to save Christmas, you need to help them get 50 stars on their list before Santa takes off on December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day. Okay. You haven't even left yet, and a group of elvish senior historians has already hit a problem. Their list of locations to check is currently empty. Eventually, someone decides that the best place to check first would be the chief historian's office. Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. This seems to be the planning the chief historian was doing before he left. Throughout the chief's office, the historically significant locations are listed not by name, but by a significant number called the location ID to make sure they don't miss anything. The historians split into 2 groups, each searching the office and trying to create their own complete list of locations. There is just one problem. By holding 2 lists up side by side, this will be the puzzle input, it quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists. Okay, so this is an example they give. Maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list, then the second smallest number with the second, and so on. With each pair, figure out how far apart the 2 numbers are. You will need to add up all these distances. For example, if you pair up a 3 from the left list with a 7 from the right, the distance apart is 4. Okay. All right, so it seems we have 2 lists. We have the left list and the right list. By far, we need to pair up numbers in each position. So it seems like we have to sort the lists first. And after sorting them, we'll be getting the distances, or the how far apart each number, each entry in a given position is from the other one. And then we add up all these distances. So in this, they give us an example. So here, after sorting, they are saying in the example list above, the smallest number in the list is 1, and the smallest number in the right list is 3. So the distance is 2. The second one, the distance is 1, and so on and so forth. So we need to submit our total distance. All right, let's get our input puzzle and see how far we can go. I think I'll be doing this in C. Let's try it in C first. All right, so I already have an opened C. Let's increase the font so that it's pretty clear. And also let's download our list so that we can save it as a file. So let's create a file here, input.txt, and all right, so okay, so we shall let's start by including some numbers, some files. Of course, we will need stdio for printing everything. Let's also include the standard library, stdlib. Let's start there. Okay. So we will take int argc char v, and by default it's return 0. Okay. Now we will take our input file as an argument. So let's check if argc is less than 2, then let's just print an error saying, let's say, you must provide an input file, and let's print to std_error. Okay, and after that, let's print the usage. Okay, so let's say if our program is parso, let's call this one program and input file txt. All right, and then let's exit with a -1. That should be okay. Okay, now let's assume we have the file, so we will have the input file. At the beginning, let it be null. Okay, let's also have the input file name. Okay, so the input file name is equal to argv, the second argument. And then let us say input file is equal to fopen, where we will have input file name. We are just opening it for reading. And if we could not open the file, so if this is null, we shall say that, all right, let's print an error. Unable to open this file, and let's give it input file name, and also exit with an error. Let's say this is exit also -1. Okay, so now we have managed to open our file at this level. We would like to read line by line, as we can see. So we will create a new character. Let's call this line. Let's also how much we've read, or the return value, a size read, and let's also do this. Okay, and I think we have a problem. We need to define GNU source. Okay, so this error is gone. Now we are going to be using the function called getLine, and we shall say while read equals getLine. We are reading into line, and this is len, the length of the line, and then this is the file stream, so that will be the file. While this is greater than 0, okay, so we've managed to read a line. Let us scan. So let's create an input. Let's call these numbers. So as we can see, our input, each line has 2 numbers. So let's just copy. It seems similar, so I'm just going to brute force this. So if we manage to read a line, let's scanf, and we will scan from the line, and the format will be an integer. I'm not sure the integers would work, but let's see. Maybe these are not big enough to beat an integer. Anyway, so we would like to scan. This will be into number 0, the first one. The second one will be put in numbers 1. Okay. All right, assume this works. Let's see scanf. Okay. So scanf, we just read the formatted input from S. So S is the input, and the format is as given. Okay, so going back, let's say we've managed to read our numbers. Let's try to, for now, let's try to print them and see whether everything is working fine. std out, numbers. Let's try to print this. Numbers 0, numbers 1. Okay, let's see whether this is fine. Let's open up a terminal, GCC, or let's compile, and we can see that we have a problem if we don't provide an input file. If we provide an input file, okay, we have a segmentation fault. Where is the segmentation fault coming from? All right, we need to figure out where the segmentation fault is coming from. Numbers. All right, let's see. Let's recompile this with like that. And next, let us all right, let's see, what am I missing? Let's GDB puzzle. Okay, what's going on? Input. All right, so it appears the reading part has a problem. We have a problem at get line. All right, okay, we need to solve this. Let's see, I think we can say maybe line is null. I don't know why this is giving us a problem. Yes, okay. So this line is null, and I don't see any problem with this. All right, let's see. Get line. Okay, so the function is not part of POSIX, and let's see. We still have the same problem. Okay, seems like we had to make line null right from the beginning, and our numbers have no problem. Let's see, is this the last number that we have in the input? Yes. Okay, so we are reading the numbers properly without any issue. We can remove this printing. Okay, we are not doing much error handling in this parsing of the numbers, so that could be necessary. Now, going back to our problem, we would have to, as it says, we have to sort the numbers. So to get the distances, we have to kind of store them in a buffer, then sort the buffer, and then compare. Okay, so let us, because this is C, we don't have buffers right from out of the box, so we have to create our own. Let's create a simple buffer. Type def buffer. So a buffer shall have a pointer. Usually this is supposed to be like a void, but since we know what type we have, they are all integers. Let's say this is a pointer of int. Let's also say the capacity of the buffer, and then let's also keep the length of the buffer. I think things get easier when you're working in Rust. All right, so let's say we would create a buffer. Create buffer. And then we shall take the capacity as, okay. So we shall create a buffer buff. We will say buff.ptr is equal to, oh, this is supposed to be struct, sorry, I forgot about that. So is equal to int, let's start with a simple calloc. Okay, so this will be capacity, and then the size is size of int, right? And then we could do some error checking here, but I don't think we will run out of memory in this case. So the length is usually 0, and the capacity starts out to be capacity given. So we can now return the buffer. Okay. Next, as we read the numbers, we will be pushing them to our buffer. So let's create a means of pushing to the buffer. Buffer push. This will take a pointer to a given buffer and a number to push. So if buff ptr, if the buffer is full, we might have to do more error handling, but we are not open sourcing this as a library for someone to use, so we know who is calling this. We shouldn't worry so much about them. If this is full, then the capacity is the same, so we should be allocating more elements. So we shall say, let's say this is new is equal to int calloc. One way would be to realloc this. Okay, this is buff capacity times 2, and its size of int, and then we can do a mem copy. This I think requires string. I'm not sure. Possibly, yeah. Looks like this requires a string. We shall be copying to the new memory. New memory, and from the old one, that's void. We are copying from, and the size is size of int times buff.len, right? Okay, so again, we probably shouldn't be doing this because the allocator is smart enough. In some cases, it could just expand the memory, so this is not needed. I think we should just, let's just realloc, right? So we can just realloc the buffer pointer, so it will do all the mem copy for us. Only that this time now we would have to specify times 2 times size of int, because the size in this case is taken in terms of bytes, but an integer has 4 bytes, so that's kind of required. And we can just say that this is all not needed. Buff.ptr is like that, and then we can say the capacity has doubled. Okay, and if that is true, then if that's handled, then we can say buff.ptr buff len plus plus is equal to num, and I think let's just take this as a void. Again, if you're doing some error handling, this shouldn't be a problem. You should be able to handle errors, like if a realloc returns null, or if the buffer provided is a null pointer. You should be able to handle that. All right, so let's create 2 buffers here. Buff1 for the first column, or for the first list of entries. This is buff2. Okay, let's see. Okay, and if this has happened properly, then again you could do some checks here to check whether the return is okay. this scanf returns properly. If it returns a negative, something went wrong, for example. We just check that this is fine. Anyway, for serious programming, error handling is necessary. Okay, so in this case, let us push. All right, let's create our buffers. Create buffer. So this will be buff1. Okay. And then buff2. So create buffer. Let's start out with a small capacity. We have 1000, but let's start out with 100. Usually you never know how much this could get, how big this could get. Or assuming everything is fine, buffer push. We shall push the first buffer. Numbers. This is number 0. And buffer push. To buff2, we shall push numbers 1. Okay, so if everything goes well, let us check how much we've printed, how much we've read into the buffers. So buffer lengths. All right, I think this is LD. Let's see, buff1 length, buff2. I think this is dot instead of pointer. Okay, let's first check how far we've gone. Again, UCC, or let's call this puzzle. All right, so it seems everything is working fine so far. We've managed to read all the 1000 entries provided. Next, we need to sort. So we would be sorting our buffers. So let's provide a simple sort function. Buffer buff. Okay. And so I think here in this case, we can just do the naive sort. Just keep everything simple. So we shall say size Ti j. Okay, again, this is if you have a large array, then this is not a very good way to do. You could just do merge sort or other better sorting algorithms. So for I equals 0, I less than buff len I plus plus. For j equals 0, j less than, again, that could start from 1. Don't want to risk it. J plus plus. Okay. Now, if let's sort in ascending order. If buff ptr I is greater than buff ptrj, then let's swap. Let's swap what's at I and what's at j, and of course we need to write our own swap function. So our swap function will take an integer array and index size t I, size t j. So we shall say temp is ptri and ptri is equal to ptrj and ptrj is equal to temp. Okay, so that's swapping. Should be fine. Let's see whether this sorts fine. Sort, is it sort buffer? All right, let's call it buffer sort. Okay. Buffer sort. Let's sort buff1. Buffer sort. let's also sort buff2. All right. Now, at this point, our buffers are sorted. And now we need to compute the distance. So let's create a new variable here called distance. I think we could we just use int? I don't know. These are large numbers. Let's just use this size t. And let's write a function, get distance. So this will take two buffers, buff1, buff2, and initially our distance is 0, and also we have an index. So let's just loop through the whole buffer. For index less than, again we have assumed that these are only buffers that we made, so usually you'd want to check that these two have the same length, so you don't cause buffer overflows and such kind of memory errors. So let's get the difference. So we are interested in the difference, and it's absolute. So we don't have negatives, so that means we might want to check. So we should say diff is equal to buff1 ptr index minus buff2 ptr index. Okay, so if diff is negative, we want to change that to positive by just taking a negative, else just add distance plus equals diff. Okay, and then we can return the distance. All right, let's check. Is this fine? Distance is equal to get distance, buff1 and buff2. Let's see what distance we have. Let's put this to stdout, and let's say distance is distance. Okay. Again, if we run the terminal, gcc parser, let's see. All right, so let's check whether this is correct. If it's not, we might have to do some debugging. All right, so this is the correct answer. We'll be right for part 2. Thanks for watching. If you like this video, please like and subscribe. Thank you very much.